Okay, today in IM2 we are going to be studying solving quadratic equations with complex solutions. So you'll notice that these are the ones we're familiar with, and like this, with one or two solutions. And the no solution ones are the ones that we're going to learn about complex roots. So there's a couple different things we're going to be learning in this unit, and they're going to be helpful in evaluating all quadratic equations. So the first thing we're going to look at is the exploration one from your journal. So if you want to get out your journal, that might be helpful. They give you these 6 graphs and these 6 equations, and they want you to match them, but they don't want you to solve for x or do anything else. So what you're going to be doing is using the a, the y-intercept, and the discriminant to match. So for example, if you look at the first one in a, okay, we see that a is a positive, so that means it's a happy graph. My y-intercept is 0, so I could find that on the matching graph. And the last thing I could do is do my discriminant. So it would be b squared, so that'd be 4 minus 4 times 1 times c, which is 0 this time, so it just is 4. So that tells me it's 2 solutions. So here is the answer to that one. The graph is E. This is the one that goes to A. Okay? It has a y-intercept of 0, it's a happy face graph, and it has 2 solutions. All right. So you can pause and try to do the rest of them, or we can do them together. So for B, we have A is 1, so that's a happy face graph. Our y-intercept is 1, and if I do the discriminant, I get 4 minus 4 times 1 times 1, and that is 4 minus 4 equals 0. So this one has 1 solution. So now you're going to find the graph that goes to that one, and that is D. So we're going to put a D here. This is E. Okay, so D has 1 solution. It has a y-intercept of 1, and it's a happy face graph. Okay, let's look at C. C is a happy face graph, again, happy smiley face, because it's a positive A, and my y-intercept is 2, and now we're going to look at the discriminant, so it's b squared minus 4 times 1 times c, and that is 4 minus 8 is negative 4, so that has no solutions. So our last happy face graph would be C, so C is C, and we can tell that because it has no solutions, has a y-intercept of 2, but it's still a happy-faced graph. All right, let's look at D. D has a sad face graph, okay? We don't want to, that looks like an A, so let's erase that. Okay, so it's a sad face graph, okay? And the y-intercept is 0. And now we're going to do our discriminant, so it's 4 minus 4 times a, which is negative 1, plus times 0, sorry, and so that's going to again be 4. So we look for a graph that is, and that would be 2 solutions. So we're looking for a sad face graph. Look at A, that was A actually, and it's 2 solutions. It's a sad face graph, and the y-intercept is 0. So there we go. So I did get A. Okay, the second one is we're going to look at the sad face graph that has a y-intercept of negative 1, and the discriminant would be 4 times minus 4 times negative 1 times negative 1, so that would be 4 minus 4, and that equals 0, so that is 1 solution, okay? And so that, we look for the graph that goes with that. That is going to be this one, F. Okay, we have a sad face graph. It has a y-intercept of negative 1, and it only has 1 solution. And you can probably guess what the last one is, but we might as well prove it to ourselves. So it's a sad face graph. It has a y-intercept of negative 2, And when we do the discriminant, it's 4 minus 4 times negative 1 times negative 2. So it's 4 minus 8. So that's negative 4. So that is no solutions. So we're looking for a sad face graph. Here we are at B with a y-intercept of negative 2. And so that answer is B, and it's sad facing and no solutions. Okay, so now you realize that you can look at any graph and get a lot of information about it before you even solve it. Okay, now we're going to do a couple of problems from your journal. This is number 2 and number 7. So the first thing you want to do on number 2 is get it into standard form. It is my practice to always move everything to the square, so that's what I do. If you do it the other way, you're going to get a negative, so I just avoid it. Okay, so I'm going to use the quadratic formula. X equals negative b, so that's going to be negative negative 4, plus or minus the square root of b squared would be 16 minus 4 times a times c, all over 2a. So that's going to be positive 4 plus or minus the square root of 16 minus 4, which is 12, okay, just remember that, all over 2. So the reason we want to look at this is because we're going to say, oh, we're going to have 2 solutions because this is positive. So I'm going to simplify the square root of 12 to 4 times 3, so 2 square root of 3. So I get 4 plus or minus 2 square root of 3 over 2. I need to simplify this. Remember, you always want to simplify. So I'm going to factor out a 2. I get 2 plus or minus square root of 3 over 2. Those cancel. And my final answer is 2 plus or minus the square root of 3. All right, and you can see the answer is there. I didn't mean for those to pop up yet, but we still have to do the work, so let's get going. So for this one, it's already in standard form, so I'm going to go ahead and do the quadratic formula. X equals negative b plus or minus the square root of b squared, so that's going to be 64 minus 4 times a times c, all over 2 times 4. So that's going to be negative 8 plus or minus the square root of 64 minus 192, all over 8. Okay, so this becomes the square root of negative 128. So that is 64 times 2, so I'm going to get negative 8 plus or minus 8i square root of 2. This is like this, negative 64 times 2, so that's 8i square root of 2. So that's how I got that. And again, we need to simplify, so I'm going to factor out an 8, and I get negative 1 plus or minus. You always want to have something there because negative 8 divided by 8 is still negative 1. And this leaves an I here with a square root of 2 over 8. So that cancels. Our final answer is negative 1 plus or minus I square root of 2. And there it is. So having the answer there was kind of a hint to you that you needed to cross cancel, but other than that, that's how you do it. You had to simplify. Okay, we're going to solve this problem. It's a little more complex than most, so we're going to do it together. So a baseball player hits a foul ball straight up in the air from a height of 4 feet. As soon as it says from a height of 4 feet, we know that that's our starting height, and so that makes 4 our C. And then it says off the ground with an initial velocity of 85 feet per second. So that is our B. Okay? So they want you to start and write any quadratic function that represents the height of the ball seconds after it hits the bat. So I changed it to X and Y. That's always my habit. And so this would be where you would put the H if you put an H, and this would be the T if you wanted to do that. Okay? But I just left it as X and Y. Then they say, when is the ball 110 feet off the ground? So we're going to set up an equation with 110 as our ending height. It's not actually where the ball ends, but they're asking you, when does the ball hit 110 feet? Okay, so we put 110 feet in there, then we have to subtract it before we try to solve. So we get 0 equals negative 16x squared plus 85x minus 106. Okay, now we're going to put it into the quadratic formula. So x equals negative b plus or minus the square root of 85 squared, which I figured out was 7,225, minus 4 times a times, don't forget your negatives, they're very crucial here, of 106 all over 2 times negative b, which is 16. I multiplied it before I did it. That's a bad habit to get into. So negative 16. So now we've got x equals negative b plus or minus the square root, and this is the square root of 7,225 minus 6,784, and so that equals 441 all over negative 32. So we are lucky because this is a perfect square, so we're going to get negative 85 plus or minus 21 all over negative 32. So then we do the simplifying, we get negative 85 plus 21 over negative 32, and we get and this is going to be a negative number, and then we do negative 85 minus 21 over negative 32. And first you do this part, and then you divide. First you do this part, and then you divide. And these are the answers that you'll get, 2 seconds and 3.3 seconds. So this represents the ball on the way up, and this represents the ball on the way down. Because as time passes, it goes back down. All right, then they're going to ask you to solve for when the catcher catches the ball 6 feet from the ground. So how long is the ball in the air? So again, they're saying that it gets hit and it's going to land in the catcher's mitt right here at 6 feet. So we want to know how long is it in the ball? How long is the ball in the air? So now we're looking for the time. Okay, so we're looking for the 0. So here's our problem. We're going to subtract 6 from both sides. We get negative 0 equals negative 16x squared plus 85x minus 2. So again, we're going to use the quadratic formula. X equals negative b, still 85, plus or minus the square root of 7,225, which is b squared, minus 4 times a times c. Again, don't forget your negatives. That will really mess you up. All over 2 times a. Okay, so we get x equals negative 85 plus or minus the square root, and I'm going to do that over here again. So we get 7,225 minus 128. So we get 7,097. Okay, and this time it's not a perfect square. All over negative 32. So when you take the square root of 7,000, the square root of 7,097 is approximately 84.24. So for this problem, we're going to call it 84. So our two formulas are going to be negative 85 minus 84 over negative 32, and that one equals negative 169 over negative 32, which gives us an answer of approximately 5.28. And the other answer is negative 85 plus 84 over negative 32, and that represents negative 1 over negative 32, and that represents how quickly the ball started. So the 5.3 seconds is the ending one. That comes from this answer. The other one relates to the ball right after it was hit. It started at 4 feet and hit 6 feet 0.3 seconds later. So that one doesn't apply to this answer. This is the only one that we're looking at because that's how long the ball was in the air. So that was a really detailed problem, which leads us to this, your exit ticket. So remember, you're going to give the approximate answer for this problem, and then you're going to find the maximum height. So the approximate answer means you simplify or you don't leave it in square root form. So good luck with that, and you are on your own.